Hi everybody, this is Brendan here with Common Motor. That's common-motor.com on the internet, and today we're going to talk about what it takes to convert your turn signals system to LED. So what I have in my hand here is an LED. LED stands for light emitting diode. It's an acronym. And LEDs are popular because they're low current, they don't put out heat, and you can conserve battery power on the bike versus an incandescent bulb or your standard type bulb. However, the conversion from an incandescent bulb to LED has a couple of tricks to it. And when you're dealing with the turn signal system on the bike, we have to do some rewiring in order to make that possible. So other than actually changing the bulbs in the signals themselves to LED, there's more involved with the flash relay, how the wires come together and are routed, and how your grounds work, etc. So in order to get to that, we have to first understand how the bikes are wired up initially. So this is a wiring setup for, let's say, your 350 Hondas, 360 Hondas, 450s, 550s, 750s. They're all wired up about the same. And what I have here on the bench is a mocked up turn signal wiring setup, much like it will be on your bike. And I'm going to explain each piece and explain how it's connected, so then we can do the LED conversion and it all makes sense. So here's a mocked up turn signal system here on the bench as it would be on your bike. We're going to start with the battery because that's where all the electrons start with. And they start at the negative side of the battery, not the positive side of the battery. A lot of confusion there. People think it goes from positive to negative. In fact, it goes from negative to positive. In the battery, we have it connected to this chunk of metal and device here. This represents ground. This would be the same thing as the engine on the bike, the frame on the bike. All the metal things are now one big negatively charged terminal. Off of ground, to each of the signals, we have a wire. This one for this side, and this one for that side, and they are clamped to the actual metal housings of the turn signals because that is conducting the current. It goes through the light bulbs, out of the light bulbs to each of the wires here, again green for one side and yellow for the other, and they run into this switch here, which would be the turn signal switch you would have on the bike. Out of the switch from a single wire into the flash relay, which does have a polarity to it. Each terminal is marked positive and negative, so you have to make sure you hook that up correctly, and then back to the positive side of the battery. In addition to that, we have our turn signal indicator, which would be on the gauges of the bike. And from that, we have a blue wire and an orange wire. Now, the way this is wired up from the factory is a bridging circuit, means that it kind of goes between the two sides, left to right, and when you turn one side on, this flashes, and vice versa. So let me turn it on and actually explain how this works, right? So I'm going to turn on this side here. So for me would be my left side on the bike is flashing, and my indicator is flashing. However, the indicator is not getting its current through this bulb here. It's actually pulling current through this bulb. And that seems kind of weird because it doesn't light up. But the indicator doesn't need that much current to light. So there is actually electricity running through this bulb here into the gauge bulb, out of the gauge bulb, and it merges up here at the switch. Now, if I take the ground connection off of this bulb, this is going to keep blinking. Watch. Right? It keeps blinking because its ground connection is actually happening through this bulb. And if I flip the switch over, this is going to start to blink, but that's going to turn off because, well, I disconnected the ground from that side. Watch. So this side's now flashing, but our bulb has turned off here. Watch what happens when I reconnect the ground. It turns on. Because the ground circuit for this bulb is being pulled through this side now. So this thing always gets its current from the opposite side that's flashing. But that's because it uses an incandescent bulb. When we switch it over to LED, it's going to be a completely different circuit. But it's important for you to understand that the current runs both directions through this little incandescent bulb. So we have swapped over all of the bulbs now to LED bulbs. We have LEDs in each of the signals themselves, and we changed out our indicator bulb in the middle here with an LED as well. We have our electronic flasher relay, which we had from earlier, and most importantly, we have this little thing right here, which is a diode. As I mentioned earlier, LEDs want to have current running through them in a very specific direction. Now, the way the indicator bulb was wired up before is with the blue and orange wire, each one of those being the bridge wire to the left and right sides. Have to wire it totally differently now. One side of it, right now I have the orange connected to straight to ground up here, and then I have the blue going into the diode. It splits left and right, and then this is where I would tap in to either my left or right side. Right now I have the green ones attached to the left side and the yellow one attached to the right side. We're going to turn it on and you're going to watch it all flash. And this is not flashing. And the reason it's not flashing is because these connections are backwards. Let me turn it off real quick. You flip the connections over and we'll watch it change. It's not always clear to know which way to wire this up. It can only go one of two ways. So if yours isn't working, reverse the connections like that, turn it on, and there we have it. Again, the current must flow only one direction through the diode, through the LED, which is a diode, and then the secondary diodes here are what help keep the current from jumping over. So if I switch to the other side, right, that side's on, but we're still getting our proper flashing happening here at our indicator bulb. This is the most complicated part about this conversion, is wiring up this little secondary diode in the system here and knowing that the orange and blue wires, one's going to go to ground and the other one's going to be the lead wire for the left and right sides now. So one of the more common troubleshooting problems we get is in regards to the flasher relay. Now this is what we call an electronic or a low threshold flasher relay, which is needed for the LEDs, but it also works with incandescent bulbs. And when it's wired up correctly, the bulbs will blink as they're supposed to. However, if it's backwards, let's show you what happens. I'll just flip the wires over on it right here, and it just turns on. So if you're trying to troubleshoot it and your system just turns on but doesn't flash, there's a good chance you have this wired up backwards. There is a positive and negative mark on each of the terminals. The positive one would hook to the black wire in your harness, and the negative one would hook to the gray wire in the harness. So the other thing is, here's a regular flasher relay that is current based. So we use this one instead. This doesn't work well with the LEDs at all, but we're running incandescents. Let's see if we can get it to flash. It may not flash. See how slow it went? This is a current based, and it has to draw a lot of energy through it in order to trigger it. So LEDs don't draw that crazy level of current. So if you put one of these in with LED bulbs, not going to work. So that's all there is to do an LED conversion on your bike. It's not that difficult, but again, the diode thing is a little confusing, so I hope this video has helped clear that up for you to make the conversion a lot simpler. Again, this is Brendan with Common Motor. It's common-motor.com on the internet. Make sure you follow us on Facebook as well as Instagram. Subscribe to our newsletter via our website, and of course, subscribe to us right here on this YouTube channel, and we'll see you next time.